What's a log of 10 plus a log of 1,000? Which law over there applies? One of them does. Well, the first one does, right? And you get the log of what?
10 times 1,000?
10 times 1,000, yeah.
She had 2.
Now, after you've done one of these, I've got no problem at all with it. Matter of fact, I encourage you to take your calculator and check yourself.
Whoa.
Okay? The calculator will do the log of 10. Turns out it's 1. It'll do the log of 1,000. Turns out it's 3. Give you the log of 10 times 1,000, which is 10,000, and the log of 10,000 is 4. And if you got better working memory than I have, you've heard 1 and 3 and 4. 1 plus 3 is 4. Okay? Now, it's new, so you probably don't have as much working memory as you would if it wasn't. But that's why you do, that's why you practice, okay? So you don't not try to sort everything out. But anyhow, you can plug this into the calculator and you can plug this into the calculator and see that they're even, okay? Now, there's this wonderful thing. I can tell you what the log of 10 and the log of 1,000 are because log, L-O-G, means log base 10. So log of 10 is 1 because 10 to the 1 equals 10. Log of 1,000 is 3 because 10 to the third is 1,000, and so forth. Okay? So, you know, I've intentionally picked some easy numbers here, but I also ask you to, like, okay, replace log with natural log. That says natural log of 10 plus a natural log of 1,000 should equal natural log of 10 times 1,000 equals a natural log of 10,000. Okay? Now you don't know what the natural logs are, but you plug them into your calculator, it's going to work. If it works, you know, if you replace log with natural log, the rule still applies. Or if you replace it with log base 2 or log base 3 or log base 476, which is one of my favorite bases. Easy to do mental arithmetic with that one, right? Okay? Understand? Understand that whatever log I use here, as long as I use the same log for all of them, log base 2, log base E, which is the natural log, okay, it's going to work. Now I do log and natural log because you have those buttons in your calculator and you can check to see that it really works. And you should do that with every problem. I'm not giving you that many problems for now, but we'll be continuing this idea. And learning to solve equations like this, which are pretty easy once you get these rules, okay? Okay. Well, let's say, let's look at this equation, okay? You got 2 to the 3x minus 7 equals 9. And let me tell you something that I'm seeing in your homework. Y'all are getting really pretty good at following instructions, okay? I'm pretty well pleased with that. Pretty well pleased with a lot of things I'm seeing here. You're getting pretty good. I give you instructions that I've never been able to give a class before, and most of you are getting them, okay? So that's very good. So, you know, I'm going to give you some more instructions. And I think you'll be able to do them from what I've seen. Okay, let's say we got 2 to the 3x minus 7 equals, not equals 9, equals 5 to the 4x minus 3. Okay? Well, let's take the log of both sides. We can do this. Officially, this is because of the one-to-one property of logarithms. Nobody ever connects that. They just say, oh, okay, you can take the log of both sides. But it's in your book. Okay? in the part that I just gave you. So we can take log of both sides of this equation, right? Anything, you might not understand why we're doing that, but is there anything that looks very strange about just taking the log of both sides? Other than you've never seen it before, or maybe you have, okay? It's like taking the square root of both sides or squaring both sides. We log both sides. Clear cut it. No. Okay. Well, what's the log of 2 to the 3x minus 7? What rule applies?
The second one?
The second one, yeah. So that's like log of a to the b, right? Where a is what for this expression? A would be 2, right? And b would be 3x minus 7. So this is 3x minus 7 log 2 equals, same thing on the other side, 4x minus 3 log 5. And I did log 2 like it's a log base 2 because I'm kind of used to doing that, and I'm not very careful. Okay? Well, we solved this for x, and it's very easy to solve. We don't have time. We don't want to take time to solve it. But you've solved things like this. You just use the distributive law and put your x's on one side, your numbers on the other side, and you have a solution. Just keep your wits about you and use the laws and the rules that you know how to use, and you find out what x is. It's going to be in terms of log 2 and log 5, so at the end, after you get your exact solution, you can approximate it with your calculator, right? Or you can go out and find a big old thick book of logarithms, you know, 6-figure logarithms or something like that. You don't want to do that. Okay, make sense? Not hard. There's nothing hard about this if you know the rules. It's just, here's 2 new rules. Those are the only rules you really need. There's another one that's similar to that. Like if it was minus here, then you'd have to divide. There's an obvious reason for that. Okay? And we're not going to worry about that one today. I'm not going to ask you about that one. We'll expand our vocabulary to that one simple extension, and then we'll have the laws. We will be able to solve any equation like this. Okay? That's pretty powerful. Just logarithmic equations can be really, really important. Okay, very good.